Space, we're told, is silent. The vacuum cannot carry sound waves, those compressions and rarefactions of air molecules that our ears interpret as noise. Yet spacecraft have returned with recordings so unsettling, so alien, that they evoke primal unease in anyone who hears them. These aren't sounds in the traditional sense. They're electromagnetic screams, plasma waves, and vibrations translated into frequencies our ears can process. What makes them terrifying isn't just their strangeness. It's what they reveal about the violent, dynamic, and deeply foreign environments beyond Earth. Here are the most disturbing sounds ever captured from the cosmos, each grounded in rigorous science and each genuinely unnerving. Saturn's radio emissions, the planetary roar. In 2002, the Cassini spacecraft entered Saturn's orbit and deployed instruments to measure radio and plasma waves in the planet's magnetosphere, the magnetic bubble that surrounds Saturn and interacts with the solar wind. What Cassini's radio and plasma wave science, RPWS instrument detected, was converted into audio frequencies, and the result is deeply unsettling. A sound resembling howling wind, crackling static, and something almost like breathing or growling. The science. These are not sound waves, but electromagnetic emissions called Saturn kilometric radiation, SKR. Radio waves with frequencies between 10 and 1,300 kilohertz. They're generated by the interaction between Saturn's rotating magnetic field and charged particles from the solar wind and Saturn's moons. As electrons spiral along magnetic field lines, they produce these radio emissions, similar to how Earth's auroras generate radio noise, but far more intense. Saturn's magnetosphere is enormous, extending over 1 million kilometers. The radio emissions vary with Saturn's rotation and the solar wind's intensity, creating an ever-changing symphony of electromagnetic noise. Converted to audio, it sounds like the planet itself is alive and breathing, a slow, ominous exhalation from a giant. Jupiter's auroral emissions, screams from the king of planets. If Saturn's sounds are unnerving, Jupiter's are nightmarish. NASA's Juno spacecraft, which entered Jovian orbit in 2016, carries the WAVES instrument designed to detect electromagnetic and plasma waves. The recordings from Jupiter's polar auroras, converted into audio, sound like something from a horror film. Piercing shrieks, otherworldly whistles, and chaotic bursts of noise. The science. Jupiter has the strongest magnetic field of any planet in our solar system, about 20,000 times stronger than Earth's. Its auroras are powered not just by the solar wind, but by volcanic eruptions on its moon Io, which ejects tons of sulfur and oxygen ions into space. These particles are swept up by Jupiter's magnetic field and funneled toward the poles at tremendous velocities, creating the most powerful auroras in the solar system, hundreds of times more energetic than Earth's. The sounds are radio emissions in the range of 7 to 40 kilohertz, generated by electrons accelerating to nearly the speed of light along magnetic field lines. The electromagnetic environment around Jupiter is so intense, it's literally deadly to spacecraft electronics. Juno is specially shielded to survive. What you hear in the audio conversions is the electromagnetic signature of particles being accelerated to extraordinary energies and colliding with Jupiter's atmosphere, a cosmic particle accelerator screaming into the void. Earth's chorus, the dawn chorus of the magnetosphere. Even Earth contributes to the cosmic soundscape with something called chorus emissions, or dawn chorus, a phenomenon that sounds like birds chirping at sunrise, but with an uncanny synthetic quality that feels deeply wrong. The science. These are very low frequency, VLF, electromagnetic waves, typically between 0.1 and 10 kilohertz, detected by satellites in Earth's magnetosphere. They are generated by electrons trapped in Earth's Van Allen radiation belts, donut-shaped regions of charged particles held in place by our planet's magnetic field. During geomagnetic storms triggered by solar activity, these electrons interact with plasma waves in a process called wave-particle interaction. The electrons oscillate, creating electromagnetic waves that rise in frequency, hence the chirping sound when converted to audio. This happens most intensely at dawn, in magnetic local time, when the orientation of Earth's magnetic field relative to the Sun creates optimal conditions. What's eerie is the organic quality of the sound. It genuinely resembles birdsong, yet it's produced by invisible forces in the vacuum of space tens of thousands of kilometers above Earth. A reminder that nature creates patterns that repeat at vastly different scales. The Singing Comet, 67P's Oscillations. In 2014, the European Space Agency's Rosetta spacecraft rendezvoused with Comet 67P Churyumov-Gerasimenko and discovered something unexpected. The comet was singing, emitting oscillations in the magnetic field surrounding it. The converted audio sounds like a low, haunting drone with rhythmic pulses, almost like a deep, alien heartbeat. The science. Comets are not inert rocks. As they approach the Sun, solar radiation vaporizes surface ice, creating a cloud of gas and dust called a coma. This outgassed material becomes ionized by solar ultraviolet radiation, creating a plasma environment around the comet. The Rosetta Plasma Consortium instruments detected oscillations in the magnetic field with frequencies between 40 and 50 millihertz, far below human hearing range. When increased in frequency by a factor of about 10,000, they become audible as the eerie droning sound. These oscillations are thought to result from the interaction between the solar wind's magnetic field and the newly created ions in the comet's coma, a phenomenon called wave-particle interaction. Essentially, the comet is surrounded by an invisible, vibrating electromagnetic field as it interacts with the Sun's radiation and the solar wind. No two comets would sing the same song. Each has a unique voice determined by its composition, outgassing rate, and distance from the Sun. Black hole acoustics, the deepest note in the universe. In 2003, astronomers using NASA's Chandra X-ray Observatory detected something extraordinary. Actual sound waves propagating through the hot gas surrounding a supermassive black hole in the Perseus galaxy cluster, about 250 million light-years away. This is not an electromagnetic translation. These are real pressure waves, actual sound, though at a frequency impossibly low. The science. Galaxy clusters are filled with extremely hot, tenuous plasma, ionized gas at temperatures of millions of degrees. This plasma is dense enough to carry sound waves, unlike the vacuum of interstellar space. The supermassive black hole at the center of the Perseus cluster is actively feeding, pulling in surrounding material. As it does, it launches jets of energetic particles that push against the surrounding plasma, creating ripples, sound waves, that propagate outward at about 1,000 kilometers per second. The frequency detected is a B-flat, 57 octaves below middle C, about 1,000,000 billion times lower than the lowest frequency humans can hear. The note has been resonating for about 2.5 billion years. When astronomers raised the frequency by 57 and 58 octaves to make it audible, the result is a deep, rumbling drone, the voice of a black hole reshaping the structure of an entire galaxy cluster through sound. This is the deepest note ever detected in the universe, and the fact that it comes from one of the universe's most extreme objects, a black hole millions of times more massive than the Sun, adds a layer of cosmic dread. Voyager's crossing, the sound of interstellar space. In 2012, Voyager 1 became the first human-made object to enter interstellar space, the region between stars beyond the influence of the Sun's solar wind. The crossing was detected by Voyager's plasma wave instrument, and the recordings are profoundly eerie. A thin, crackling hiss that sounds like cosmic static. The science. The Sun emits a constant stream of charged particles called the solar wind, creating a bubble called the heliosphere. At the boundary, the heliopause, the solar wind collides with the interstellar medium, the sparse gas and plasma between stars. Voyager's instrument detected plasma oscillations, electromagnetic waves caused by the density and temperature differences between the two regions. The interstellar medium is denser and quieter than the turbulent solar wind. The instrument measured oscillations in the 2-3 kHz range, converted directly to audio. What you hear is the electromagnetic signature of the sun's influence ending. It's the sound of true interstellar space, a region no other operating human instrument had ever sampled. The static and hiss represent the ambient electromagnetic noise of the galaxy itself, the background radiation that fills the void between stars. It's the sound of profound isolation, of being truly beyond the protective bubble of our home star, adrift in the galactic deep.